It's not really combining like terms, it's combining like terms. Putting them together. Okay? In order to combine or combine like terms, you must know what in the world is a like term. Anybody care for speculation? No, good. So far, so good. Well, like terms are terms that like each other, apparently. Okay. Let's say I've got this. Let's say I have 5x plus 3y minus 2x plus 4y. First of all, terms in math are separated by addition and subtraction signs. Okay, that makes terms. So this right here has 4 terms. You have 5 times x plus 3 times y minus 2 times x. There are 4 terms. 1, 2, 3, 4. And it's very important when you look at those terms that you look at the sign that comes in front of them. Okay? This plus goes with the 4. It doesn't go with the 2x. This minus goes with the 2x. The plus goes with the 3y. We don't write it down, but there's a plus there. Okay? Now here's the crucial part, because just like distributive property, this is also one where many, many people take a long time to figure out, and it's not that hard. Okay? Terms are very social people, but besides being very social, they're very cliquey. And you guys know what cliquey is. I don't know how you would, but apparently you do. In other words, this. The little x's, they're not really friendly to the y's. I don't know because they're different. I don't know. But the little x's like their other little x's. They get together and they form their own little group. Okay? What happens here is this, though. See, we start off with 5 x's. And by the way, 5 times x means you have this. It's a shorter way of writing this. Multiplication is no more than a different way to write addition. Okay, I have 5 x's here, but then I have to take away 2 of those x's because it's a minus 2x. When I combine 5x and minus 2x, I have 1, 2, 3 x's left over. Now it's important that you realize this. The little x's did not turn into x squareds, because somehow people get it confused with multiplication. When you multiply x times x, you get x squared. If I add an x plus an x, it doesn't change the x's. You just get more of them. So 5 x's minus 2 x's is 3 x's. Now the little y's don't want to be left out of the whole clicky party thing. So here are 3 y's. They want to get together with the other 4 y's that are over there. And when they get together, how many y's are there? 7 of them. They don't change into y squareds, mind you. There are 3 y's, y plus y plus y, and then another 4 y's, all getting together in their own little group. They combine to give you 7 y's. When you combine like terms, that's what happens. They come together. You really the simple short way is you add the numbers in front together to get what they are. In other words, you have 5 minus 2, that's where the 3 came from. The 3 plus the 4, that's where the 4 comes from. But the letters don't change. I can tell you're slightly confused. If I have 3xy plus 4y minus 8, and I asked you to combine like terms, you're going to say to me, I can't do anything because they're so cliquey, they only get along with people like them. There are no people like each other here. These guys are xy's, this guy's a y, and this guy unfortunately has no letter with him at all. So they don't get together. This is already as simplified as it can be. However, if by some chance I would write this up here, now Holly says, look it, I've got some friends here. They're both xy's. I can combine them. Well, the book calls it collecting. So the next time you see the word it says collect like terms, this is what they mean. What happens when I collect or combine 3 xy's and put another 6 xy's with them? They don't turn into x squared and y squared, by the way. They don't change. There's just more of them. It's like taking 8 7th graders and putting them with another 5 7th graders. You get 13 7th graders. You don't get 13 14th graders or whatever that would be. Okay. What do I get if I put 3xy plus 6xy, Taylor?
You get 9xy.
9xy's. Okay. This person here doesn't have anybody, but let's just say I end up putting a negative 15y there. So now I have 4 y's, but then I have to take 15 of them away, which is a tough thing for us to realize because now I'm in the hole. If I have 4 y's, I know there's still y's, by the way, but what is 4 minus 15? Holly?
Negative.
There you go, negative 11. And we're just going to put Mr. 8 down there because he don't have no friends and that's the way it goes. Okay, same thing is true for this. If you would happen to have 6x squares plus 3x minus 7x plus 4x squared. Again, letters, they're very, very discriminatory. These x squareds, because there's 2 of them getting multiplied together, don't like just the little x's. They're just a little bit lower in the kingdom of x's. Okay, x squareds will only go with x squareds. They're funny that way. And if I have 6x squareds and I put them with 4 more x squareds, now I finally have how many x squareds? 10 of them. I have 3 x's and 7 x's leave, which couldn't be possible, but if it does in our world of x's. Okay, any barons? 3 minus 7 is negative 4. Negative 4 x's. And that is it. Now, to throw one small little complication thing in the whole world of this. Do you think that the xy's like the yx's or not?
No.
Yeah.
Yes.
Yes.
Why, Ashley, is it the same thing?
Because you're just switching around, doesn't matter.
What property in math says that?
Associated. No,
Commutative property, yes. Okay. This means x, 8 times y times x. Okay. In multiplication, it doesn't matter the order you put it. So if it helps you to think this way, this is the same thing as 8xy. It doesn't matter the order when you multiply. So yes, these guys do like these guys. They get along quite nicely. They're just in a little different order. Okay. And when I add them together, if I have 4 of them and add 8 more of them, you end up with this. Now let me tell you, in math, when they give the answers to that, they usually go alphabetical. So when I read the answer, it's going to be 12xy. But it's the same thing as 12yx. So if you on your paper put 12yx, please don't ask me if it's right. Just know that letters can be in any order. It's preferred that they be in alphabetical order just for correcting purposes. Alex Ballmer.
Say what if you had 4x to the first power,
Which is just 4x, by the way.
oh, alright. Would it,
It's assumed 1. Anytime you don't have an exponent, it's assumed 1.
no, would it combine with an x, if it was just x, if it actually said x one? Would it combine with
Yes,
x?
it would. 4x to the first power plus 3x would be 7x to either first power or no power, but that's it. Yes, Taylor.
Before, like, you had just, like a regular 8 in the problem, you just, once you
Regular numbers will only combine with other regular numbers.
Okay, so if there isn't any more regular, then you just put it at the bottom.
Yep,
of
it
the-
just, if something doesn't combine with something in your answer, you just plug it at the end. Okay, so here, let's do a big one. You do this problem for me. Let's say I have 13x plus 9xy minus 6x squared plus 12x squared minus 8 plus 2xy. They're all planning a big hoochie whatever party, a big Lollapalooza, if you will. Who's going to get along at this party, and who's going to snub their nose at the rest of the letters in the like term world? Or who's going to dance and have a good time, and who's going to be left out in the proverbial cold? What goes together, what doesn't go together? It could be that the x squared wearing their little stiletto shoes don't like the other people who can't afford those nice stiletto shoes and have to wear the little pumps, the flat ones that are easy to walk in. Meanwhile, the poor x's are, wait, did I say x's? Meanwhile, the x's have to wear their flats or their sandals or whatever it is. And because the commutative property of addition and subtraction, really it doesn't matter what term when you combine goes first. Although it's acceptable, usually you start with the ones that have the highest exponents. So let's see. Something that combines there in the wonderful world of mathematics. Charlie, what combines? Just give me something that combines here.
11xy. I mean, that's not.
Okay, yes. XY and XY you have 9 of them, you have 2 more of them. They get along quite well. We have 11 XYs. That's one. So you don't have to, once they combine, they are gone. Don't need them. Alright. What else happens there? Ava Wyrick. Anybody else getting along at this party?
6x squared plus 12x squared.
Is,
It's 18x squared.
now here's where I said you have to be very careful. You always take the sign that's in front of it. This is actually a minus 6x squared. And this is a positive 12x squared. So if this is a minus, you actually have to take it away from that. So you end up with
6x squared.
6x squared. And like I said, it's just general policy that usually they put higher exponent things first. If you put it after, it does not matter. So now my x squareds are gone.
Oh.
How about Mr. 13x? Gonna have a dancing partner or no? No. No other x's, so you just tack him on at the end. This minus 8, nobody else, normal numbers. This is simplified as much as you can do at this point. Ashley.
I don't really get what happened to the plus 12x squared. Why isn't it combined with the x plus 6x?
It did. That's where I came up, but it's a minus, you have to remember it's a minus 6. If this was a positive 12 and you're taking 6 of them, you have 12x squareds. Oh gosh, do I really want to draw 12 of these? You have 12x squareds. Why didn't I make it a small number? It's really hard to draw pluses and x squared at the same time. You have 12x squareds, that's what this means. Minus 6x squareds means you have to take 6 of them away. So these all go away, and 2 in this row here. That leaves you with 6. You have to watch. That's why the signs are in front. Yes, Caroline.
How did you get the plus sign before the 13x?
It's just a assume. If it doesn't have a minus sign, you put a plus. I mean, you can't just put it there because then if you didn't put a sign between there, then it would end up being multiplied. If there's no sign in front of something, it's always an assumed plus or addition sign, as we say in my world. Perfect. And it's your lucky day, children, because I have actually a worksheet. And on this worksheet, you are allowed to do it right on this worksheet. And they are probably a lot easier than the ones we just did. They did combining like terms. And the bottom part is adding integers.
That was their
Wait, that's okay.
Oh, yeah.
Oh, Ms. Me.
Oh, Maya. Take a look, if you will, at those last problems where you're supposed to just be adding. Okay. Please know that if something's not in a parentheses, and it makes you more comfortable to put it in a parentheses, by all means. Matters not. I would think 10 minutes and you could probably accomplish this. The other thing I would think is if you are at all questioning yourself, please come to a higher authority. It would be me. I will set you straight, or at least less crooked than the path that you're on right now. For example, the first one, negative 11K, negative 4K, negative 15K.
Which one?
Yes, 98. Love it. Let's say you bought a new $5,000. And the next day you buy it at $2,000. You won't buy it 5, you won't buy it 8, you can get it now buy it. Two. I'm pretty sure. Most of these you could just do in your head. That's a 1. You're gonna be 8. Yes. Now, let me take a look at it. Eight minus 2. If you have 8, you take 2 away. So, you hold 1 to 6. Do you like that non-binary reference? This one here, negative 8 and People, if there's no number in front of the letter, there's a 1 there. That helps you, makes you feel better. Plus p is plus 1p. Minus 10 is minus 1. Yes.